Good evening, everybody. We're Group 2, which consists of me, Alake Peoples, Gerardo Castrio, and Gregory Castamento. And this is our Wi-Fi presentation. Next slide, please. Part 1, Finding Password of WEP Encrypted Packages. Our team was successful in cracking the key used to encrypt capture file B provided from class. Here is a brief description of our software used and considered our research. Air cracking captures wireless network packages, cracks the network password by analyzing packages, supports FMS, PW, PTW, correct, and other attacks against WEP passwords. Air getting integrates several tools and provides single command line interface for security analysts. Walks through the process and interactions. Crack Station uses lookup tables to crack password hashes, has a word list containing thousands of passwords. It is built by extracting words from the Wikipedia databases. Next slide, please. Installing the software. Consider using Linux or Windows subsystem for Linux WSL to exclude the statistical attack. 2. Using Ubuntu, install the software suite by entering the following in the command line as shown below. 3. Move the capture file to the C drive. Create the folder for WEP practice using the code below. 4. In your terminal, change directories from following this example. And 5. Finally, execute program. Next slide, please. Executing the statistical attack. Some important things to consider. 1. There are 606,446 wireless network packages. 2. From 352 routers. 3. You need about 250,000 IVSs to crack a 40-bit WEP key. 4. You must select the index number of target network. And 5. The index to select is number 16. Next slide, please. Eureka! After selecting index number 16 with 259,967 IBS, the key is found. The password is BBBBB, lowercase. Next slide, please.
All right. Thank you, Lucky. Okay, now I would like to share some of my learning experiences from cracking the WEP password from the exercise of the capture file B. And although we all had different experiences, we try to combine everything in here into our experiences. But overall, this is our general experience that we all came across together. And some of those were about strengths and weaknesses. So, for instance, I would consider a weakness that downloading and extracting the air crack for Windows was very time consuming and a false positive for virus detection with Windows Defender, as I am using the Windows system operating system. And so there was various ways of doing this. By downloading the file, you could take it to the C drive and then put it into a bin folder, for instance, and then run it from the command line. However, I was unable to do that because of Windows Defender would detect it as a virus, you know. And um, I try to do older versions as well, and it would also bring these false positives. So he created all this extra work. Finally, through a little bit more research, um, I was able to look. I asked Google, to be honest, a Google AI mode, and he walked me through a better suggestion, which is WSL. And by downloading the Linux version for Windows, um, through the installation process, I was able to get a smoother experience, and and it actually worked out very well. Another weakness I would mention is the air crack does require you to buy or obtain an additional hardware device, which is the USB Wi-Fi adapter, which would be necessary for sniffing or trying to capture a file. In this case, we already have a file capture from class, and so it was unnecessary really to do it, to use that Wi-Fi extension. Um, but look, fortunately, we were able to use the file, the capture file B, for for this exercise. Some of these strengths that I would consider that, as mentioned, no sniffing was necessary for the exercise part of part one, and it was very friendly with Windows subsystem for Linux (WSL). Very easy to use, very straightforward. There was a little bit of reading involved and research into understanding the different types of attacks. Um, and so, because there's one for WEP, another one for WPA, WPA2, as my colleague Greg will talk more about that next. Um, and one more thing is installation and use with Windows, as I mentioned already. But overall, the experience was very good, very interesting experience, and surprising, and that things do work out eventually as you keep working, trying to find the answer or the process. All right, next slide, please.
So first attempt on Apple Silicon. This was basically an adventure in futility. As it turns out, Apple has locked down the Wi-Fi interfaces and explicitly disabled monitoring. Um, also, uh, Apple has removed legacy Wi-Fi frameworks, which makes it difficult, if not impossible, for Wireshark to extract the kind of packets that are needed for this kind of analysis. After trying this for a while, I gave up. I decided to try on my Debian Linux installation. So on Debian Linux, I installed Wireshark, created groups, installed AirCrack NG, enabled Wi-Fi, and I had to do this because I didn't use Wi-Fi. I used Cat6. Everything was hardwired. Also, I had to install the kernel module to cover this. It was the interface was WLP0S20F3 for whatever that means. But yeah, so. So part two, cracking a weak password. Um, the steps I had to do for this was I had to identify the network and extract the useful traffic for use in the attack. My home network has two SSDs, one for me and one for my guests. And I'm going to approach this by, creating a simple password for my guest network. So I started up Wireshark and started to capture the appropriate packages on, well, across the entire network. I used my cell phone to disconnect and connect, and in order to create the packets that we needed in order to match the password. Once that was done, I used the password cracking utility, the one that we downloaded, Error Crack NG, to match the password using a dictionary file. What I did was I used one of the words in the dictionary so that it would be guaranteed to be found. Okay, so here we have the process. First, it was necessary to capture from a given channel, in this case, channel 5. Then I had to run the results through a dictionary file, and as you can see, it did find the simple password. The type of packet is called an EAPOL. I'm not sure what that stands for. And in the case of WPA2, it actually, has to match the password using a dictionary file because of the fact that, WPA2 uses a one-way hash. So, learning experiences from cracking a weak WPA2 password. This is from the perspective of the person doing the actual, attack. The strengths are of this approach are that word lists are readily available. If a password is in the word list, then it should be easily discoverable. Some word lists contain substitutions like mnemonics or commonly like elite speak, if you will, that kind of thing. The weaknesses of this approach are if the user stays away from common mnemonics, it defeats the purpose, defeats this, or makes it difficult to discover the password. If they stay away from dictionary words, then it makes it difficult. WPA2 uses a one-way hash, as I mentioned before, to store passwords. So this means that the password can never be decrypted as with WPA or WEP. Okay, part 3, cracking a strong password. So this is basically round 2, but with a more complicated password. Same steps, packet sniffing, password cracking for WPA2 using the tool, strong password set with special characters and length. Okay, here's the discussion for this particular go. In this case, the password was using the same mnemonic approach that we had discussed in class. By coming up with a phrase and then replacing it with the first letter or various other things. The only reason I was able to crack this is because I actually put it into the dictionary, that I use to crack passwords. I did it so that I could show it being found here. But if the system had to actually generate this password, in other words, if you had to write a brute force, algorithm to create a number of different passwords, any number, then it would have to create millions of passwords just to get to this one. A brute force attack would take a lot longer. This makes it imperative that you use a complex non-dictionary word to protect the system's that you that are important, as it makes it more difficult for a casual hacker to penetrate. Okay, part three: learning experiences. See, okay, this is also from the perspective of the hacker. Um, Strength was a strong password. The strengths of this particular approach become greatly diminished. There basically are no strengths. Um, Weaknesses of this approach: if the user has a significantly strong password, the time needed to crack it could be hours or potentially, in some cases, years. Um, because, I mean, for instance, one of the things that I had done when I was pursuing the first one was I wanted to create a small application or a small tool that would generate all 8 character passwords from all A's to all Z's, and it turns out that that was somewhere in the line on the order of 430 million plus passwords, and that would have taken hours to generate, at least, maybe even a couple, maybe even a day. And then it would have taken, I don't know how long it would, the tool would have had to have searched through all of those in order to actually find the password that matched the hash that was in the sniffed packets. So therefore, I mean, it just seems like if you again, if you protect your systems with a long password, then it should make it nearly impossible for the casual hacker to break in. So it's important to remind ourselves what kind of WPA or WPA passwords can be cracked. WPA passwords themselves cannot be instantly broken due to cryptographic flaws. Instead, the success of cracking WPA, WPA2, or WPA3 passwords depends entirely on the strength of the password and the specific configuration of the wireless network. Dictionary words, I mean, the vulnerabilities are dictionary words, passwords consisting of a single standard dictionary word. Um, uh, Short passwords, WPA passwords must be at least eight characters in length. Predictable patterns and common substitutions. Passwords that use simple leet speak or number for letter modifications, stuff like that. Um, Default manufactured passwords, pre-configured passwords like the ones that are printed on routers and then sent to you when you get them. Leaked or reused credentials, passwords that the user has previously used on websites that suffered a data breach.
All right, another thing I would like to mention here is our conclusions. Once again, as a team effort, we feel that these conclusions do match in general with our, and we have agreement that a strong password, for instance, would use the combination of lowercase, uppercase, numbers, of course, the letters, and special characters. And then as you increase the number of digits, it'll take a longer time to crack a password. So the more digits you include, which you can do this by combining several phrases that you might have, that for you make sense or you remember them, like different words or even a sentence you could think of. And perhaps in each of those letters, you can replace them with either, as I mentioned, special characters, lowercase, uppercase, and numbers. As for a weak password, normally this would fall into the category of using easily guessed words such as the 1, 2, 3, 4, 5, 6, 7, 8, 9, or easy words to guess that are such as password and then another set of numbers, pet names, and mother's maiden names. And the reason for this is because there's different forms of attacks, such as dictionary words attacks, and these are included it, in a set of a list, dictionary words, and so the attacker can use these this list of words, which are commonly used or guess words. Uh, and once again, if not having enough digits is also another characteristic of a weak password. Okay, next slide, please. And as additional conclusions, based on the experience of this assignment, I would say that a lot of things, just with a lot of things that are related with computer science, as I'm starting to figure this out, the environment setup is important. And that takes actually research and trying to find out which machine uh, you're using, if the software is compatible, uh, and the way to use it as well. Because I came across another software where you can download it, let's say as a Git from GitHub, but then you have to use Visual Studio, for instance, to run this aircrack software, and they complicates things a little bit. So instead of that, you have these other options such as WSL, where you can use it as a Linux, like if you were using Linux on Windows, and easily run the commands. So there's different ways or environments or versions of doing things, and so it's important to do the research, and eventually you do find your way around, which was very exciting. Also, consideration for additional hardware may be needed as you do your research. Different programs require perhaps USB Wi-Fi adapter, to capture a packet, as is in the case of aircrack. Um, but there are other software such as Wireshark that may not necessarily require that. Anyways, it was a great exercise, and um, yeah, I look forward to learning more about this. Next slide, please.